So we're ready to talk about a little thing called Redux. And I feel bad because this first workshop that we're going to do with Redux is we're going to do something a little bit painful before, like it's going to get worse before it gets better, so to speak. Because we're going to have you write some code, some like really ugly looking boilerplate code. And the point of that code is it's going to make it very transparent what some very beautiful code is going to do in the subsequent part of the workshop, our grand finale. But for now, let's talk about what Redux is, and also what it's not. So what Redux is about is it is a small, very small, actually we may not even install Redux during the course of this lecture because we're just going to write it ourselves because it's that simple. That doesn't mean that understanding the patterns that we implement with it is simple. It's actually something that is fairly difficult because there's quite a bit going on. There's a lot of steps that can be taken, which is why whenever I'm working with a Redux application, it's very important to just kind of like repeat the steps of the things that are going on. We'll see pretty soon. I'll probably be walking many of you through them as we go throughout the workshop. But Redux itself is this very simple small library that just gives you a couple of functions. And the function that we're mostly concerned with is create store. And create store is just a function that returns an object. It's what we would call a factory style function. There are two ways of creating objects like in this world that we know. We use the new keyword with a constructor function, or you could just have a function that returns an object. It does the same thing that the new keyword does, only more explicitly. That's what create store does, is it gives us an instance of an object called a store. And what the store is used for is it just has a couple methods on it that are specifically good at dealing with a state object. Just a JavaScript object that we would think of as state, the state of our application. So what we want is we want state in our React applications to be managed no longer just by to be no longer managed by our components. We don't want to have our state live on our components anymore. We want all of our state to now live in this store, this single object, which will be available anywhere in our application. Because we can see the advantage of this, of having all of our state living someplace totally different. What would be an advantage of getting this to happen?
You wouldn't have to pass stuff down through props all the time.
Yeah, we wouldn't have to pass stuff down through props all the time. It's really annoying that we have this single big app container where all of our state lives, and anywhere that needs it, it's all got to be passed down, and that's just a lot of writing. But if we have this store object that contains all of that state, then it can just like flitz through our application, just like and merrily like sprinkle bits of state like wherever it needs to go. You get some state, and you get some state, and you get some. It's the Oprah of applications. It's very nice. And I want to ask for any more because I really think that is like the big advantage is that no longer does the state of our application and getting that state to our components, it no longer needs to be contingent upon the shape of our render tree. We no longer have to freak out about putting state too far down on our tree with the risk of it having to move further up again. Because now we just have our store. Everything will be in the store.
Is that including forms?
That's an excellent question. And the answer is if you want. If you want to store form data on the store, you could. If you don't want to, then you can still use this .state. I find it simpler to keep form data in regular React components rather than have it clutter up my store because this pattern we've been doing with the app container for the past 3 days is just one of many different ways we could have gone about shaping our Juke application. We could have had state live in the artist component and in the albums component and all these other different things. But kind of we want to like gear you up to this idea of state living in a single place. And specifically that state is application state. It's like the state that really matters. It's not state that's ephemeral. We want it to stick around. It's going to need to be used in a lot of places. So now that we're going to have state living in this other place, in our store, what does it seem like our store needs to be able to do? What method that our React components have right now does the store need to somehow be able to do as well? Yeah, it needs to be able to set the state. We need some kind of way of having this state in our application and then changing it, and then having our React components know that they need to re-render in response to this change. And today this is going to be when we implement this, it's going to be ugly. And then the next day it's going to be beautiful. So get ready for that. So here I've got a little bit more of a minimal dopey pets. Got like new puppy, we can add, right now we can add Bubba again. Kind of like just a more minimal version of our solution from last time. So what I'm going to do is I'm going to make a new file here, and I'm going to call it reduxstore.js. So before we even start writing anything, I want us to think about, there's kind of like these like 3 steps that we need to do to be able to write and manage our state with Redux. So step 1. These are steps I recommend taking every time you start. What are the actions that a user can take to change something? And just a note, like these can be active, like clicking a button, or passive, like loading the page the first time. You might think of just like the decision to load the page. It's kind of like an action as well. Okay, so here in Dopey Pets, what are the actual user actions that a user can take? Yeah, we can like type puppy's name. So every time the user presses a key, we're collecting some form data right there. So this is actually going to be something that we're going to ignore because it's a part of a form. But if we were going to maintain form data in our Redux store, this is what we would think about. So this is totally legit. What's another action? Yeah, we can go back and we could say just like page load. What else? Yeah. Let's call it what are we doing when we submit? What's like the goal of submitting? Yeah, like adding the puppy. Add puppy. This is the one we're going to actually deal with today. But these 3 things right here, in Redux, these are called action types. And applications that we write with Redux begin with thinking about action types. What are the things that a user can do? And the reason that we think it in terms of the things that our user can do is because it's only the things that users do that's going to cause things to change over time. It's going to cause changes to our state. So this is good for now. This is a good place to start. So step 2. What does the state of our application look like? How to represent it as a JavaScript object. The exact same thing that we've been doing with our initial state object, or our this.states in our React components. If we were to model all the state of our application as a single JavaScript object, what would that look like? So for Dopey Bets, what do we got here? Yeah, we've got an array of puppies. So we've got puppies, and if we were to just show the page without performing any different actions, we would just want it to start as an empty array. You also, of course, don't want to break a certain law given to us by sages of ancient wisdom. Anything else? Yeah, we have the input value. Whoops. What does that start as? Yeah, just an empty string. Cool. Anything else? The answer is no, that's it. Sorry. That's about this is all of our state for now. And the input value, if we decided that we were just going to handle form data with React instead of Redux, we could exclude it. But let's go ahead and let's say that we are for now. We want all of our form data on our Redux store as well, because we've got type puppy name as well. We've already got an action type for it. So now step 3. How does this state object that we've represented right here, how does this state object change in response to each of our actions? So when we add puppy, how does that change this state object? When we type puppy name, how does that change this state object? The way that we're going to answer this question is with a function. So we're going to write a function. It's going to answer this question of how does state change every time we have an action. So what do we need to know in order to answer this question? Yeah, we need our previous state. We need what every time a change happens, we need to know what our state looked like before. What else do we need? Yeah, we need the action. We need to somehow know the action type. Let's go ahead and call this action type for the moment. So the way that we can answer this question now is with something nice like a switch statement. Is anybody here still like unfamiliar with the switch statement or still feel shaky with it? Because it's something that I feel like in JavaScript kind of like went out of fashion for a while and now is like back in. So it's but basically it's just a nicer way of writing a big string of if-else statements. Okay, so basically we switch on some kind of value, and then you write a case in that switch statement for each value that you're switching on. So what are the values that we were switching on here?
The things we define in step 1?
Yeah, we're switching on the action types. We're saying if this action type is type puppy name, then we're going to do, then the state is going to change in some manner. And and just remember, with a switch statement, we always need to break after each case. In case we add a puppy, we're going to need to do something. Typically, we end with something by default. So if we get an action we don't recognize, then we haven't made any changes. So any new state that we have is just going to be the same as our previous state. So let's just go ahead and we'll just say, by default, we'll return previous state. Something like that. So now we're set up to answer this question of how our state object is going to change in response to each of these actions. So now the way that we answer this question needs to follow a very important rule, which is that when we answer this question, that is, with our change state object, this function that we're writing needs to be a pure function. This means that we can't have any side effects. We can't have any AJAX calls. We can't have anything asynchronous. All we can have is something that is perfectly understandable. We just need to perform a calculation and return a new object representing our new state, or state that is the result of the change that we performed, the result of the action. So something that you'll see actually fairly frequently, you'll see this in the workshop, is before we even get started, is we'll say new state equals object.assign empty object previous state. It just makes a copy of our previous state. So then what we can do is we can affect these changes onto this new state object and return that. And this way we never change our previous state. Different ways you could do this, but this is just a convention that you'll see fairly often. There are reasons you should be careful with this particular pattern. And you'll probably run into them in the workshop. I can't wait. It'll be fun. But this is going to make sure that we don't hurt our previous state. We're going to return something new. We're going to be pure. Just like array.prototype.slice or concat, we're going to be pure. So how is this? So what's our new state? So how are things going to look every time we type a puppy name? What's going to change? Yeah, our input value is going to change. It's going to say, we're going to have our new state dot input value. And it's going to increase by something. So right now, because we're just passing in a basic string like our action type right here, we don't have any way of telling our function right here, like what's changing. All we know is like the action type. But we can fix this if we assume that instead of just a string representing the action type, we're passing in an object called an action. And what this action has is it's going to be an object that has a type. which will be just one of our big types, and any other data that we need to describe what that change is going to make, some kind of payload. So if we do this instead, we could say switch on action.type. We could say that when we type our puppy name, this action is going to contain our new value. Let's say that it's going to contain like the entire new value, not just a single character. So we can just reassign new state.inputValue to action dot, let's say it's new value. So when we receive an action for type puppy name, it's going to have a type of type puppy name. A little bit of an unfortunate collision of the word type right there. Isn't the English language great? And it's going to have new value equal to like some string representing the input value we want to change it to. That's what the action is going to look like in this case. And then we'll return new state. So how about add puppy? What might the so we know that the action object is going to have this type, add puppy. And what else could it have? Yeah, it could have our new puppy, which is going to be like one of these puppy objects that has like an ID and a name, like we've seen before. So now here's where things get, here's the thing that you're going to run into. So now here we've made a copy of new state. So does that mean now we can go back to our old ways of saying like new state.push action dot new puppy, something like that? Yep. The answer is no. I'd probably not ask if the answer was. We still don't want to do this. We still don't want to mutate this array. So our state object contains an object on it. So if we mutate this array, if we do a side effect, then this function is no longer pure. Even though the new state is a copy. Because the previous state and this new state object are both going to contain references to the same puppies array in memory.
And that's what object is assigned, because it just points references to the same objects in memory of the previous state.
So what object.assign does is it makes a copy of previous state, but it doesn't make a deep copy. Yeah. So
they're still pointing to the same.
why not? Because I said so. No, because I guess they just didn't want to do that. If you want deep copies, then I highly do suggest Immutable.js for this. It's very good at making deep copies, but it doesn't because of maybe, I don't know, like worldwide JavaScript conspiracy to make our lives more difficult. But it only makes a shallow copy. So if we were to push, then our previous state dot puppies, remember it's equal to, it would still be equal to our new new state dot puppies array. So we would have corrupted our previous state.
What's the point of making the copy then?
Is we still need to, well, see, that's the thing, is we still need to be still need to be pure here. So we can't push. But here's what we can do. So we can say new state dot puppies equals new state dot puppies dot concat. Because concat doesn't mutate. It returns a new array. No, because we've made a copy of it with object.assign. Yeah. Yeah, if the contents reference an object, like an object or an array or a function, though you generally never put a function on your state. Okay. If they reference an object or an array, then that is going to be the same location in memory. So if we want to change one of them, we need to make a copy of that as well. And using something like concat or slice, we can. So now we can return new state.
Just to be clear, when we call concat, that's returning a new copy or a new array.
Yes.
That has nothing. There's no longer anything to do with our previous state.puppies. So we're just reassigning new state.puppies to something new.
Yeah, it's a totally new array in memory. Totally new memory address. Contains the same values.
Right.
But the array itself is different.
Cool.
They would not evaluate as equal if we were to triple equals them.
I'm kind of confused about that. So you said that for when you do, the new state is not a deep equal of the original state, which has a puppies array.
Mm-hmm.
So then over here, you're doing a new you're reaching out to that puppies array and adding the action.new puppy to it.
What we're doing is we're reassigning new state.puppies to no longer be the same array in memory that previous state.puppies was. Instead, it's a new array in memory that has the same values plus this new puppy that we're adding.
I just thought that would still affect that same puppies array, and that would not be different.
That's not the case.
So
The previous state.puppies is still going to be the array it was previously. Because you can kind of think of these as...
Okay, so now we're going in and kind of making that that shallow equal. We're changing the values of it, like going in and changing the actual puppies values.
we're going in and we're changing the value of the puppies array.
Right.
So like before, like if we were to, let's like pretend like the memory address is like memory address like 14 for the array of previous state.puppies. And when we make our shallow copy of new state.puppies, that's also the same array in memory. It's still memory address 14. But here we're reassigning new state.puppies to be this new array that we're creating. So let's say that like it somehow gets assigned to memory address 15. So we're reassigning new state.puppies to be pointing to the array at that location. The previous state.puppies is still pointing to the old array at memory address 14, let's say. Let's keep these in here.
So we'll always have reference to our old states.
Yeah, so this way, if we were to go back and get previous state.puppies before we make this action, it will still have the old puppies array, the one that we had before we changed it.
So does this seem like an extra step, like we can cut out the middleman by having new state.puppies equals previous state.puppies.concat?
Yeah, that would be kind of like the same thing here. We still have new, so because at this point, new state.puppies and previous state.puppies are the same thing. They're the same array, so we just need to get a new copy of it. Yeah, I mean this is not my favorite pattern of doing things, like making this like new state thing. What I prefer to do is I prefer to return object.assign previous state, and then go ahead and like work the new values in as like the third object, third argument to object.assign. But I feel like that's like a little bit, it's a little bit more opaque than what we're doing right here. But unfortunately, it is something that is just something that we're not used to. So it's something that we just have to take care to practice and to remember.
What if your previous state had a value that was pointing not to an array, but pointing to an actual object? Then if you wanted to change that object, what you have to do like another object dot assign
Totally.
inside the thing.
So if like if like we had like say like new state dot, if we had like say like a favorite puppy and we wanted to change like the favorite puppy's name, it would have to be something like new puppy dot favorite puppy equals oops, new state dot favorite puppy equals, you know, and we'd say like prev state dot, or like a sorry, object dot assign new object previous state dot favorite puppy. And let's say the name is now going to be action dot new name.
Why not just make like a deep clone function so you don't have to like go through all this headache?
You could.
And type in all this stuff.
You could. If you could make it, you could do a deep clone. You're going to not want to for a very good reason that we'll talk about when we talk about React Redux. But you could. Just to like give you like a preview of what that thing is, that we'll lose the ability of a certain lifecycle method in React to be able to tell what parts of our tree need to re-render and what parts don't. We'll talk about that more when we talk about the bindings for Redux and React. But for now, deal with the headache because I said so. It's good for you, even though it's hard. Cool, so this function we've written here answers this third question. How does the state object change in response to each of our actions? This function in Redux is called our reducer. The idea there is that we have these actions that happen over time. And every time they happen, we calculate our new state based on our previous state and that action. So then at the end of that stream of actions that happen over time, we have some kind of like final current state. So one more thing that we're going to do here, because this is something that Redux requires by convention, which is why I've told you all to do it, is we're going to initialize our state. And the way that we do that is very clever. Is we make our initial state the default argument to our reducer function right here. So our initial state is we're going to set it as the default argument to our reducer function right here. Because this is how Redux, in its own way, that we're about to see in a moment, is going to get our initial state. So the way that in React we get our initial state is by saying this.state equals in our constructor. The way that Redux gets our initial state is by getting, all that we give to Redux is this reducer function. So it needs to be able to tell with this reducer function how to calculate our initial state. And the way that it does it is when it creates our store, is it just executes this reducer once with just like a dummy action and undefined as the first argument. So we've got this reducer. So now pretty much we are ready to say create store, and we give it our reducer. So what this is going to do is this is going to create this store object. It's going to contain our state. It's going to give us a method to change that state. And it's going to use this reducer function that we've used to change that state over time. Yes?
Can you just repeat real quick about undefined when you said the reducer will take undefined for the first time?
Yeah, actually we're going to code that right now, so to see how it works. So we can write create store ourselves. So like I said, all it's doing is it's just a factory function. So get our reducer right here. So what we do is, let's say we got this constructor function. You could also write it as a class. Say class store. Just going to return a new. Let's make it a constructor function. That'll be less cognitive load maybe. All the create store does is it gives us this like new store instance right here. So what's this store going to do? It's going to manage some kind of internalized state, which isn't going to be publicly accessible to us. So it's going to be on a variable, which the store object will close over. So we'll call this underscore state. And here's what we're going to do. Here's what's clever. What create store does is it takes that reducer function that we passed to it, and it invokes it, undefined, and say just some kind of dummy action object right here. So the way that default arguments work is that if this argument is undefined, it's going to be equal to the default value. So it'll evaluate our reducer. It'll switch on action.type, which is undefined, because we just passed in a dummy action. Won't hit on any of these cases, so by default, it'll just return this value right here, which is set to this. A little bit clever. But that's probably the cleverest thing that this does, because the rest of this is actually not all that complicated. So like, remember the event emitter that we wrote way back when we were doing sockets? That's what the store is, essentially. It's an event emitter. So the store has some methods on it. Anybody remember what some of these methods are? Yeah, it's got a method called dispatch. Any other methods? Yeah, it's got and you might recognize these methods. Very, very similar to emit and on. A little bit different because they're made specifically to do this one thing, to deal with our state, this state object right here. But they're very similar in concept. And what's one more? There's one more. There's technically two more, but one of them you should I've never used in my life, and I don't think anybody should. It's probably the most important of all. Store.prototype.getState. Here's what this does. Just gives us access to that state object right there. So that's how we get our state. So now we need the method that's going to give us the capability to change that state. And that's dispatch. Dispatch is how we're going to change our state. So what it takes as an argument is it takes an action. Somewhere in our application, we're going to give it an action that it can use to change our state. Because then at this point, we have both ingredients that we need for our reducer to tell us how our state is going to change. So all we need to do is say our new state, just going to reassign state, be the result of invoking our reducer, the previous state, and the action. Every time we dispatch, all it does is it takes this previous state that we've got here, takes the action, invokes this reducer that we've written. This is all code that we'll write specific to each of the applications that we write. This is all specific application code. And it just reassigns state to be the result of that calculation. So now the very last thing that we need now is we need some way to know when this change happened. And this is where subscribe comes in. Because every time we dispatch something, that's kind of like emitting an event. Except there's only one event that we can emit, the fact that we changed our state. So if we want other places in our application to know that this changed, then we need to subscribe listeners. We need to give it callback functions. So I'll go ahead and I'll make a listeners array, just like we did with an event emitter. So subscribe is going to take a callback function. All it's going to do is it's going to push that callback function into the listeners array. And now we'll just change dispatch to be a two-step process. Step 1, update the internal state. And then step 2, once that's done, and remember that we can be 100% sure that it'll be done when we go down to this next line because our reducer needs to be a perfectly synchronous, just pure function. No side effects, no AJAX, no set timeouts, no tricks. Invoke the listeners. Listeners dot for each callback. Just invoke it. You could pass state along too, if we want. I don't think it actually does because in these callbacks, if we say store.getState, we're guaranteed to get the new state. It's been reassigned. Any questions on how this is operating? Just like this little class we've written.
What is the listeners doing again?
So what the listeners are doing is we're assigning listeners so that every time we change our state, we can register some callbacks that will get invoked. So that in those callbacks, we can get the new state. Same way that we would register callbacks to an event emitter that we can invoke every time that event is emitted. Same concept. Except here there's just one event, changing the state.
So then the get state gets that.
Yeah, and then we can use store.getState in those callbacks to get our state.
So as listeners, where like all those callbacks, is that kind of like conceptually like render the page again and then do all this other stuff?
Absolutely, 100%. That's where we're going to do that. So one final thing we're going to do here, before I show you how to hook this up with React really quick, because that won't take very long actually, is say like we want to unsubscribe. Here's what subscribe does for that. It's a little bit clever. Is subscribe returns a function, which we could call unsubscriber, which when we invoke it, will reset listeners to be listeners.filter callback. Let's say underscore callback, just so there's not a name collision. All the callbacks except for the one that we passed in, just filtering it out using closure. So this means that if we want to, so this is just like clear interval, the way that set interval gives us an ID that we pass to clear interval when we want that interval to go away. Subscribe gives us a function that we can invoke when we want to no longer have that function fire every time the state changes. Just a clever little thing right there. This is what the Redux store looks like. You don't need to write all this yourself, though. This is what create store does when you import it from Redux.
So if you run subscribe with the callback, it pushes that callback in the listeners array, and then you run that again, and that's how you take it out.
You don't run subscribe again.
Yeah.
You run the function that subscribe returns to you.
So it'd be like unsubscriber equals store dot subscribe.
Yeah,
subscribe, which does a thing, and then you can run the unsubscriber afterward.
totally.
Okay.
Let's see how this works now with a React component. Let's save this. So let's go ahead and let's so we'll export that by default. And we don't want that in puppies. We want, let's go into our main component here. Let's go ahead, we'll import this store that we've created. Our state is no longer going to be managed here in this component. It's going to be initialized to store.getState. And when we add a puppy, we're not going to set state. We're going to say store.dispatch type of add puppy with our new puppy equal to a new puppy. So what this is going to do, store.dispatch has 2 steps now. What are those steps?
Update the internal state of the listeners.
Yeah, and it'll call our listeners. Right now we don't have any. And we have no way of changing, of getting this dot state right here up to date with store.getState. So our React component is not going to update. And the only way that this React component can update is if we perform some kind of set state. Just because we're dispatching doesn't mean that React knows what to do. It doesn't mean that it knows now that like, oh, well, I better set state. We have to tell it to do that. And the way that we tell it to do that is with our listeners. So in our component did mount, what we're going to do is we're going to store.subscribe. Let's give it an arrow function. So that every time the state changes, we're going to say this.setState, and we're just going to pass it store.getState. And we could expand this a little bit just to make it clear what's going on. So we're always getting our new state here in our store.subscribe callback. And we're just setting it on the state of this React component. So remember, so now if this component were to go away at some point, which we know that happens, we wouldn't want to continue to set state on it. So remember that throws an error. But remember that we get this unsubscribe function, this unsubscriber from store.subscribe. And what we can do is we can store it on the component just by saying like this.unsubscribe. You can just put it there. You just need to put it someplace where we can get it later, where it's associated just with that component. So that then, making its triumphant entrance into our lives, this component will unmount. When this component goes away, we'll invoke this.unsubscribe and stop listening for state changes.
Can we walk through a little bit what happens again when we call subscribe, and specifically what happens with the callback?
Yeah, so when we call subscribe, that just goes into this listeners array. And we return a function that will remove it from that array. So that then at some later point, when we dispatch an action, that's going to change our state and invoke our listeners. 2 steps. Change the state, invoke the listeners. Sorry? Change the state, invoke the listeners. Yeah, let's become a cult real quick. Change the state, invoke the listeners. Yes, wonderful. Cool.
Right, that's what I want to know.
And then what we have is we have this function. This anonymous function, which because it's an arrow function, it keeps it to this context, which sets our state, which causes a re-render.
What will unsubscribe do?
So then if this component were to go away, because say like this was the single playlist component, and we click away to go to albums or artists, we don't want to listen to, we don't want this subscription anymore. So this.unsubscribe, and we invoke it, it's just this function that subscribe returns, it removes it, so that we don't end up trying to set state on a component that no longer exists.
So the only components that will be listening is like the specific component that we're working on, like artist or albums. Like that's the only thing that's gonna like re-render and reset based on the state.
It'll be any component you write that has this little boilerplate that we've just set up, where we initialize this .state to be store.getState. This component did mount, and this component will unmount. Those components are now hooked in to our Redux store.
So you can subscribe or unsubscribe only one thing.
We could subscribe multiple things, but we're only really interested in this one thing, getting the new state and putting it on our state object. That's all we want. But in a different component, we could have another component that also does this same thing, that also subscribes. So that then when we change the state by dispatching, any components that have subscribed will re-render.
Would we expect most of our listeners to look like that, where it's basically saying, get the new state and set it?
Exactly like this, actually.
Right, okay.
Because here's the thing, is that what we've written right here, you're going to write this several times. This is boilerplate. This sucks. This is verbose. And this is what we're going, and this is something that we can abstract away, but we won't yet, because you need to eat your vegetables first before.
The component did mount. When that gets called again,
when the component comes back onto the scene.
that happens every time the state is updated.
No, the component didn't mount will not happen every time the state is updated. The listener that we subscribe will happen every time the state is updated.
Oh, that only happens once.
Yeah, we only subscribe it once,
Okay.
But-
Subscribe it once, but it doesn't only one. Okay.
but the callback will be invoked many times whenever the state is updated.
And the callback will be invoked anytime the state is updated. In the store's state.
Yeah, every time the store state is updated. Because now this .state right here is now one-to-one with our Redux store.
And could we omit the unsubscribe, and would that just cause kind of bloat and not do anything?
It would cause bloat and memory leaks and lots of other unhappy things. So don't forget it. It's just after this next workshop, you'll never need to remember to do it again. So
So the reducer only changes the state one value at a time, right? Because it's a switch statement.
we could design it to be more complex, but for now I'm going to urge you not to do that because there's a good chance that you will do something confusing. We could make it so that multiple things change in response to the same action, but just don't for now, because that's going to be confusing. Just try to focus like a single action, single change. Remember, the simpler you make things, the easier they'll be to understand, and the fewer errors we'll have. So one final thing, because we're a little bit over time and you all need to eat, is something that I think kind of sucks right now. Is that every time let's say like we had different places where we could add puppies. Is right now, every time I want this add puppy action, I've got to remember what an add puppy action looks like. And what also sucks is that like I just typed in a string literal right here. So like if I like mistype, like I do all the time, then there's a good chance that I'm going to have just like this really weird error. And it's going to be hard to debug. So for this reason, in the Redux community, we typically adopt this convention of writing functions called action creators. So that instead of typing out the object literal ourselves, we write functions that create the actions. So this would look something like this. We'd write a function that says add puppy, accepts the puppy name, and then it returns the action object. So this way we don't need to remember, instead of using a string literal, we'll use one of these constants that we've written. Because if we misspell a string literal, our linter isn't going to help us. But if we mistype add puppy, then that's going to be like a reference error. And that's going to be much louder. So we do this just to make our lives easier. So this way, instead of just dispatching a string literal, could get the action, and then just dispatch the action itself right there. We'll just import, say we'll just like export this function. Bring it in as well. And then just create the action using the function instead of typing it out. Just because this will make it so that our code is more robust. It'll be more error-proof. It's purely by convention, though. It's not required for Redux to work. This is just a pattern of writing an action creator.
So can you walk through that again, the function that you just made?
Yeah, so where before we were just saying store.dispatch object literal with type, add puppy. This is what we were doing before. New puppy, it's new, like puppy like that. Because this is kind of brittle and leaves us open to misspellings and like having to remember what the object literal takes. Instead, I've just written a function that returns that same object with a puppy name passed in. Puppy name. Just written a function to return it. And it uses the string constant instead of a string literal, just so that because linters are better at recognizing errors when you type in a variable incorrectly rather than a string incorrectly.
Can you go back to the other add puppy function?
So then when we invoke add puppy, that gives us the action object. So then we can, so then we dispatch the action object the same way that we were doing right here. And we can reduce this down to one step. We could just say store.dispatch the result of invoking add puppy with new puppy. But this is something I like to do while we're learning, so that it's very clear that we're just dispatching objects.
Oh, so that wasn't, so puppy name, you mean like, that's the puppy object. Like,
New,
in the-
oops, sorry, yeah, I've probably mistyped something here. Puppy name. Add puppy with puppy name.
I mean, yeah, like
And down here I meant, yeah. Puppy name. Sorry.
So then you have two add puppies. Okay, this is that.
So this gives us the action object, and this dispatches it to the store. This is what we were doing previously.
So we could get rid of line 31, right? What does that do?
This is just putting our new puppy object in a. Actually, I think we do want the new puppy. Sorry.
So we're creating
Yeah, not
the
the
object
puppy.
Putting that object into our dispatch.
Yeah. Yeah, I'm still caught up with the like playlist name, I think. From
Yeah,
sorry.
is it where is that exporting from?
I'm just exporting that from my Redux store
Oh, okay.
from this file right here. But there are many places we could put this.
Is this convention to have that be the same name as the function where if that state that
Same name as the
dispatches
action
happening?
type.
Yeah.
It's a helpful convention. It's a convention I use. I don't know if it's the convention, but pretty helpful, right? You know, you don't have to. It's one less thing you have to remember. Cool. It's 12:20. Cut into your lunchtime. I'm very sorry. Please don't hate me.
No worries.
But there we go. So break for lunch. I'll get things set up for when you get back.